Assalamu alaikum. Welcome to my channel M.Asif Math Corner. Today we will learn about homomorphism in group theory. Homomorphism is a mapping. Let's start. Let G comma dot and with and H with steric operator and G with dot operator be two groups. H is not subgroup of G here because we see that operator is different. For the subgroup, operator must be same. So H is different group and G is different group. Mapping phi from G to H said to be homomorphism. Actually, homomorphism preserve the operator. Be in mind that it observe the operator. It preserve the operator. Operator will preserve in this mapping. It will not change. So G with operator dot and H with operator steric we groups. Mapping of phi from G to H is said to be homomorphism if phi x dot y is equal to, here you can see that the first set has the dot operator and on the right side we can see that it is steric operator, means it preserves the operator. So for x comma y belongs to G, the range of phi in H is called homomorphic image of phi. The range of phi in H, because we give the domain to G and H is the range, G is the domain. So the domain is range is H and G is domain. So the range phi in H is called the homomorphic image of phi. Let's see an example. By an example we come to understand. So let a real number with respect to addition, as I said in the definition that operator may be different because it preserves the operator. So these are different groups. Real group with respect to addition, real with respect to multiplication, two groups, and phi is the mapping from R to R dot defined by this function. Phi of x is equal to e raised to power x. Phi of x is equal to e raised to power x. It is a function. We give the value to x and that will be the domain and answer will be range. So we have a function as a real number with respect to addition. So let x comma y belongs to real number, then the phi will be x plus y because the first group, which is a range, which is domain, is with respect to addition. That's why phi x plus y is equal to, now we start from plus and we will end on the multiplication because dot is a multiplication. So because it preserves the operator. So phi x plus y is equal to e raised to power x plus y because we give the value x to x plus y. So here e raised to power x will be equal to x plus e raised to power x plus y. So by exponential rule applying, e raised to power x dot e raised to power y. So e raised to power x is equal to phi of x. and e raised to power y similarly will be equal to phi, phi of y. Hence proved that phi is homomorphism because it preserves the operator. I hope you understood. Thank you so much. If you like my videos, please share it to others because someone need these videos. Thank you so much.